Hello everyone, welcome to my channel. I just decided to make some videos on data science, and this is my first video. As this is my first video, I will start with some basic Numpy operations for those of you who are thinking to start using Numpy. If you don't know what Numpy is already, it's a Python library that made it easy to perform scientific computation. And what kind of scientific computation? That's probably I don't need to explain too much. We can learn by doing. And today we will do some very basic operations for the beginners only. Slowly in my future videos I'll keep moving to the deeper end. But though it's a basic video, but still this will give you enough ideas, enough tools to start using Numpy today. So let's start by importing a Numpy as np. If you don't have, I'm using a Jupyter notebook. If you don't have it, you can install it. There are a lot of YouTube videos available. They're pretty good, showing step by step how to install it, how to install Anaconda package, how to install Numpy, Pandas, all these packages. Please feel free to go and get one of this. So this is just a simple list, but for Numpy you cannot use the list like that. We need to convert it to a Numpy array. So just make an array. Array looks like this. Let's make another array so that we can do some mathematical operations. Probably make it 7. Okay. Yeah, let's do some mathematical operations. They will be pretty self-explanatory. A plus B, you can see it does element-wise addition. A minus B, it will do element-wise subtraction. A times B, then A divided by B. Then this is going to be a little interesting. A power of B. So what it does, A 1 power of 3, 3 power of 7, 1 power of 2, 3 power of 4, 5 to the power 7. That's what it does. If you do A2, that means it will do A square. So A square, 1 square, 3 square, 5 square. Then A dot B. This is a very interesting thing. What it does is 1 times 3 plus, sorry, not 1 times 3, 1 times 2 plus 3 times 4 plus 5 times 7. Yes, 5 times 7. So you can see what it did. Element-wise multiplication and then adding all of the values. So this is A dot. Let's make another interesting array. That A square C. So let's see how C looks like. C looks like this. It's a two-dimensional array. Let's see the shape of array. C dot shape. It's 2 by 3. That means it has 2 rows, 3 columns. First column is A and second column is A square, as you can see. There is another thing that is called a transpose. What it does, it just rotates this matrix to 90 degrees. So the column becomes the row becomes the column. If you see C dot T dot shape, it's, oh sorry, yeah, it's 3 by 2. So it was 2 by 3, it's 3 by 2. So that's transpose. Let's make another array a little bigger so that we can show some of the statistical operations. So this is our x. How x looks like? This is an array. It has 6 elements in it. Let's do some very simple statistical operations. First, sum. This adds all the items. X dot sum, x dot max. It gives the maximum value of this array. X dot min. The minimum value of the array. X dot min. Mean of this whole array. Then x dot standard deviation. X argmax. Oh, sorry, not s, it's x. Yeah, argmax is an interesting thing. What argmax does, it gives the index of the maximum value. So the maximum value of x, here you can see, is 6. So it gives the index of 6, which is 3, 0, 1, 2, 3. You can do the same way, argmin. It's 4. It gives the index of the minimum value of the array. The minimum value is -3 and the index is 4. Okay, so next see what arrange x np.arrange 15. It gives a range of value. Lower bound is 0, upper bound is 15, so it gives the value from 0 to 15 exclusive the upper bound. It doesn't include the upper bound, so it's not going to include 15. It will return the value from 0 to 14. And look, the interval is 1. You can actually change this interval. You can make the interval of 3. Let's arrange 0 to 45 and interval 3. Let's see. So 0, 3, 6, 9. So interval is 3 now. You can see lower bound is 0, upper bound is 45, and exclusive 45. So it will return the last value will be 42. 3 less than 45 as interval is 3. Now let's save it in a variable. So x. Now reshape it. Reshape to 3 by 5. That returns a matrix. Matrix of 3 by 5, 3 rows and 5 columns. You can see the same value, the 0 to 40, 42, interval 3. It just reshape the value. You can. So next we'll do the linspace. This is upper bound 5 to 15. Let's see how y looks like. This is what y looks like. So here lower bound is 0, upper bound is 5, and it returns 15 randomly generated number from 0 to 5. That's what linspace does. So we can reshape this, but you can use the resize too, that will do the same thing. So I just want to show you both the things. Y.resize. Okay, let's return y. See, the y, before y was one single array, now it's a matrix. Let's see, y.shape. Yeah, it's 3 by 5, 3 rows and 5 columns matrix. And next, moving on to 4. Look, np.once 2, 4. It returns a 2 by 4 matrix of all ones. You can do the same with NP zeros. Yeah, 3 by 3 probably. Let's see. Yeah, it's a 3 by 3 matrix, all zeros. Here, just remember one thing, in NP by ones, you have to put two brackets here, otherwise it's not going to work. It will give you an but it will, you can do another way though. 2 by 4, yeah, this is the same thing. The two brackets are bracket like that. Yeah, now return np dot I, what, 4 by 4, yeah, this is called an I. It's a 4 by 4 matrix, a square matrix, one all diagonally all 1, and the rest of them are 0. This is an I shape in Numpy. And you can only do it with 0 and 1. You can do np dot I with any square. You can actually do the rectangular shape too. Oh, sorry. You can at least do in, you can at least actually do a rectangular shape also. np dot I, probably 3 by 4. Yeah, but you see 1 1 1, but in the last column it's all zeros, as it cannot be diagonal completely. Now let's make another array. I want to show something different, probably 2 3 5 a, yeah, np dot diagonal a. So look, you can convert this simple array A to a diagonal shape also. So that's also possible if you need it for any reason. I never use this kind of thing, but it's possible to do. np dot array, the next one, 3 4. I am doing by multiplication 3. You might think this will multiply each element with 3, but it's actually not going to do that. What it does, it repeats this array 3 times. 2 3 4, 2 3 4, 2 3 4. You can do the same. If you do 4, it will repeat 4 times. 2 3 4, 2 3 4, 2 3 4, 2 3 4. There is another one. It's called also np dot repeat. Sorry, how many times you want to repeat it? You decide, probably 3 times. It repeats each element 1 1 1, 2 2 2, 3 3 3, which is fun. Yeah. Let's make another array. Okay, actually we don't need to make another array. We already have this A. Let's use A. Let's see, np dot vstack. Look, A to A. Oh, sorry. You have to show 2 times A. Yeah. So this is called np.vstack. What it does is 1. This is our A, 2 3 5, and 2A for it just twice the element, 4 6 10, and it makes a 2-dimensional array. So that's one way of making 2-dimensional array. Then np dot arrange. Look, this arrange, it's 10 square. it just returns 0 to 10 each square of each element, exclusive 10. So 0 square, 1 square, 2 square, all the way up to 9 square. It's not going to add the upper bound. That means 10. So as you're seeing a range, it will give you a range from 0 to 10, exclusive the upper bound. Again, so now let's see some of the slicing or indexing. In that case, let's put it in a, save it in a variable n. Let's check n1, n3, 0, 1, 2, 3, so 9, or n minus 3, that gives third element from the end, from the last third element, 81, 64, 49, the last third element. N minus 5 minus 3, yeah, so n minus 5, then fifth element, 1, 2, 3, 4, 5, so 25, and then it will go another 3 down, 1, 2, 3, 4. If you do this, minus 2, minus 3, what it does, let's check. Minus 2, 0, 1, 2, so second element from the last 2, and it will keep going down as it's minus 3. It will keep going down every third element. So 1, 2, 3, so 25. Next 1, 2, 3, 4. There is no more. Okay, if it's not minus 3, if it's no, we have to do that. Minus 7, let's do plus 2, so minus 7, so seventh element from the last, 1, 2, 3, 4, 5, 6, 7, so it's 9. After that, every second element, it will go up this time because it's plus 2, it's a positive 2. So after 9, it's 25, 36, then 49, then 64, 81. Yeah, I think that's all for today. In my next video, I'll try to make a video on matrix slicing and matrix indexing. It's going to be very interesting. Please stay tuned. Slowly, I will keep moving to deeper end, as I said in the beginning. So please stay tuned. Subscribe to my channel if you like it and if you want to keep learning with me. Thank you for today.